back. So now we'll work on problems from section 2.6, implicit differentiation from web work. Problem 1. Okay. Given square root x plus square root y is 1. Find y prime by implicit differentiation. Leave your answer in terms of x and y. Okay. So square root x plus square root y is 1. Okay. A part wants implicit differentiation. So square root x is x to the power half, square root y is y to the power half, right hand side is 1. You are going to take derivative with respect to x of both sides. When you do that, you get derivative with respect to x of x to the half plus derivative with respect to x of y to the half equals derivative with respect to x of the constant function 1. Derivative of constant function is 0. Alright. On the other hand, here, derivative, because x and x, they are the same variables, the usual rules apply. Half comes down, power reduces by 1. Now here, x and y are different variables. So first apply power rule times derivative of y with respect to x, the unfinished business. Because x and y are different variables, you need to incorporate multiply by dy dx to this particular expression. Right hand side, as we said, was 0. Now look at that. You have denominator of half, so multiply both sides by half. By 2. So that takes care of this half, and this is 0 anyway. So x to the negative half, y to the negative half, dy dx is 0. Move the x to the negative half to the other side, negative x to the negative half. Divide by y to the negative half. So you have negative x to the negative half over y to the negative half. Now remember, powers can flip when you go the other side. So y comes upstairs with positive power, x goes downstairs with positive power, and there was a negative up below before. So dy dx is negative root y over root x. All right. So keep that in mind. Okay. So a part is implicit. You need both x and y variables. So negative square root y in the numerator over square root x in the denominator. Okay. Now b part is solve for y. So you have your original equation. Solve for y. So move this guy there and then take squares of both sides. So look, this is one entire item. So there is parenthesis. Square cancels the square root. You are left with y equals parenthesis 1 minus root x power 2. Now when I take derivative with respect to x, that 2 comes down inside as it is times derivative of the object inside. Derivative of 1 is 0 minus derivative of square root x is 1 over 2 square root x. Check for yourself. So when I simplify this, this distributes inside, so this 2. Okay. If you like, let me rewrite that 2 out here. 2 times 1, 2. So that was the 2 from here which went there. Those 2's cancel. And now I am distributing this quantity inside. So 1 times negative 1 over root 2 is negative 1 over root x is negative 1 over root x. Negative times negative is positive. Root x cancels root x. So you have 1 minus 1 over root x. Okay. To the one we just submitted. Okay, good. Next problem. So now they are simply asking implicit differentiation. X raised to 8 plus y raised to 8 is 88. Okay, let's expand this a little bit. There you go. X to the 8 plus y to the 8 is 88. Take derivative with respect to x of both sides. So d by dx of x to the 8 plus d by dx of y to the 8 equals d by dx of 88. This is a constant, so derivative is 0. X and x same variables, so the usual rules apply. 8 comes down, power reduces by 1. Plus x and y are different variables, so first power rule, 8 comes down, power reduces, and then times derivative of y with respect to x. That's the chain that you need to multiply it. So now you want to solve for dy dx, so move this guy over there. Negative 8x to the 7th, divide by 8y to the 7th, and you get overall negative x to the 7th, y to the 7th. So negative x to the 7th over y to the 7th. Now it's safer to be careful, so place parentheses for the numerator and denominators separately. There's a negative overall. Next problem. X to the 7th plus y to the 7th is 20. Find the derivative with respect to x. Similar story. Take derivative with respect to x throughout. Derivative of the first term plus derivative of the second term equals derivative of the third term. Okay. X and x same variable, so 7 comes down, power reduces. That's all. Plus x and y are different variables, so first the power rule applies and then times dy dx. So that's the unfinished business. Equal derivative of constant is 0. Move the 7x to the 6 to the other side. Divide by 7y to the 6th. 7's cancel, negative x to the 6th over y to the 6th. Remember to use parentheses for numerator and denominator. Next problem. All of this, x cubed plus 5x to the 7th, y to the 5th plus y to the 7th equals 7. Take derivative of both sides. Derivative, 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 and derivative. Okay. Right hand side is constant, its derivative is 0. Here, x are same, so 3x squared plus 5 is simply a constant. Now, x to the 7th and y to the 5th, there is a product there. So, you need to take product rule. Derivative of the first, second as it is, plus first as it is, derivative of the second. So, notice that 5 comes down, reduces power, and because y is different from x, you are going to take dy dx inside. Plus, here 7 comes down, y to the 6th and dy dx. All of that is 0. Now simplification. 3x squared plus 35 plus 25 plus 7 this. So here is the part. You have two terms with dy dx. Well, keep that together. Get common. You see, and these together here. All right, the terms without dy dx are kept separately. The terms with dy dx, get the dy dx factor out. All right, now I have placed parentheses around these and moved them completely. So negative all of this to the other side. This continues here. Divide both sides by this factor and you have your. So how do I write this here? So I have a numerator divided by denominator. Don't forget to write parentheses. And inside the parentheses you would fill it. 3x to the power 2 plus 35x to the power 6 y to the power 5 and denominator 25x to the power 7 y to the power 4 plus 7y to the power 6. All right, and all of this has a negative value in the front. Okay. All right, so next problem we'll start on next video. Until then.